And honorary mention this point of radius gauges as well. So as we have used our dividers previously to mark a radius on a plate, we too can use a radius gauge to determine the size of a radius on something. So for this component here, for example, this is just a piece of bar I'm using as an example. If I was unsure of the diameter of this, I could use a vernier or a micrometer to measure it. But what I'm going to use as an example here is a radius gauge. So if I don't know what this curve is, this might be the curve on the corner of a plate even. So this plate may have a curve on the corner. If I wanted to be able to tell how big the curve on the corner of this plate was, I would use the appropriate set of radius gauges. Now they do come in set sizes. So this one is a 7.5 to 15 millimeter set of radius gauges. One end tells me how big an outside radius is. And each of these plates has a number on it. So this is 8.5. If I was to try that on our bar, I'll see that there's a little bit of a gap, so that's not quite right. Let's go the other way. Let's try 10. And that 10 is a perfect fit on our bar. So that means this bar has a radius of 10. So it's a 20 millimeter diameter bar. So I know that checks out. On the other end of our radius gauges, we have fillet measurements. So it's still a radius, but this time we're measuring the inside radius of a component. So if you imagine on our dividers here, for example, the head of the dividers have a curved section here. They have an internal radius. And I can do the same thing. I can find a radius that seems about right, and I can try it inside our dividers. And that allows me to measure radiuses, which is especially useful when it comes to marking them out. If I need two components to fit together and I want to mark a radius on my plate that fits into another component, I can use these radius gauges to do just that. Always make sure when you're finished, fold them away so they don't get damaged and keep them safe.